Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, president of PCEA. Reshoring has been a buzzword for a few years now, but when supply chains are undergoing dramatic disruption and inflation is raging worldwide, what is the reality? To help us address those questions and more, we are turning to Matthew Dyson, senior technology analyst at ID TechX. Matt, welcome back to PCB Chat.
Hi, thanks very much. Thanks for the invitation to come on the podcast.
You just co-authored a white paper titled Factory of the Future. Lots of people, of course, are considering what exactly that looks like. What spurred your interest?
Well, I think it's the combination of technologies that we see being developed, but then this is Factory of the Future is then a really compelling use case for them. And so it's about how can you make manufacturing more efficient to address some of those concerns that you kind of highlighted earlier, reshoring, inflation, and so on. And how can it be more efficient? It's about incorporating sensors, incorporating cobots, incorporating predictive maintenance. And so it's one of these application areas that is both very useful to society and includes a lot of different separate technologies, each of which are kind of interesting in their own right.
So in the white paper, as you just noted, you boiled down the next wave of industrial manufacturing to a few key pivotal trends: sensors, additive manufacturing, automation, and flexibility, which I think in your research you talked a lot, as you mentioned, about AGVs or mobile robots and
Yeah.
cobots. How did you arrive at those?
Well, I think at IDTechX we kind of try and work out how technologies are going to evolve over the next 5-10 years, and so that involves talking to an awful lot of people and attending a lot of conferences around the world. Obviously, not just me, but also my colleagues. And what we see is basically these trends that we've mentioned in the white paper. And so there's lots of companies talking about how they can integrate more and more sensors into their equipment, not just for things like quality control, which is pretty standard by now, but also monitoring the machines themselves, which is somewhat less common. And so these can be all different types of sensors. They could be monitoring temperature or vibration, for example, and then feeding that data back continuously so that you can identify, this machine is vibrating a bit more than expected. Maybe we need to have a look at that before the whole production line goes down and costs a lot of money. We've also seen lots of other examples of people aiming to integrate sensors into manufacturing processes, even for things that seem kind of quite prosaic, like keeping track of the amount of parts in a parts bin. This can be done digitally. There's a little companies bringing out a little pressure sensor in there that then automatically orders more sensors when the level drops to a certain point. There's a company that makes gaskets that's incorporating an RFID tag in there so that you can check digitally whether it's been installed correctly and whether it's being subjected to the appropriate amount of pressure. And so these are all examples of not just monitoring the quality of the product that's produced, but monitoring the manufacturing process itself in real time. And I think that's the key kind of step when you hear people talking about kind of industry 4.0 and the digital factory and mass digitization and all of these kinds of buzzwords. What it's about is about continuously monitoring as many processes as possible, not just the product, but the processes involved in producing the product, so that you can identify problems early, so that you can make small adjustments so that the quality of the product is maintained, so that your supply chain can be as efficient as possible, so that you can check that installation has been done correctly or repairs have been done correctly without having to pay somebody to laboriously go around and check them manually. And all of these things will be communicating wirelessly, and you'll be able to build up these huge data sets that will then enable you to monitor if there are any other factors that could be influencing the output quality. And so it's that mass digitization that I think is the key trend here.
So I want to talk a little bit more about those data sets and just how that information is going to be reviewed and analyzed and processed and put into action. But I'm going to take a moment to mention our sponsor, PCB West, the leading conference and exhibition for the printed circuit design and design engineering industry. Coming October 4th to the 7th, to the Santa Clara, California Convention Center. Learn more at PCBWest.com. So before the break, you were mentioning about some of these the data sets and the amount of information that's going to be collected. Did your research try to get into any of the higher level systems that will need to be developed and implemented just in order to store and process that information in a timely fashion, right? Because I mean, we could be looking at billions and billions of data points,
Yeah.
in a typical factory that need to then be processed very quickly in order to adapt in real time.
So it's a really interesting point. So additive X primarily focuses on the hardware. So I'm coming at this more from the materials, sensors, antenna sort of side, but I have looked into the software to some extent. And so this touches on the kind of idea of sort of edge AI. And so how can you reduce the amount of data that needs to be transmitted? And of course, one way to do that is to do some of the processing at the relevant location before it gets transmitted, and that can reduce power consumption because you then don't need to transmit as much data. And so that's certainly something that people are doing. I suggest that in some cases you're not necessarily needing to take readings every tenth of a second or something. If you've got a manufacturing line and you just want to monitor the vibrational frequency or amplitude of some machine, probably detecting that every few minutes is probably completely adequate. Because that it's going to, the vibrations are gradually going to get worse if there's a problem with the machine, over days. And so, relative to say, many of the other applications where continuous data monitoring is needed, such as autonomous vehicles, I would say that in many places, actually, your factory is more straightforward. And in some cases, it can just be a check just after installation. So these gaskets that I was mentioning, which I heard about at a conference a couple of weeks ago. Someone will install them, I'll scan them there'll be some sort of scanner that will check have they been seated correctly, which of course you can't tell once they've been installed. And so those kind of issues are relatively straightforward. I think there's an interesting point in the sort of business models that people are adopting. So some of the manufacturers of kind of large scale equipment are very keen to kind of offer a full solution with all the digital services in there, and they've got their own teams of software engineers doing all of the data management. And then there's the sort of other approach, which is to kind of outsource all of that and have just a completely separate provider that would maybe provide just the sensors and that would stick onto the machine, and then they'll manage the data for you and just give you a sort of dashboard on your phone or on one computer with few of the kind of tangible insights. And so it really depends on the kind of company strategy and the resources, the sort of software resources that they have available, as to whether they want to bundle all of this sort of digital factory equipment ideas into their products, or whether they want to just work with somebody else and do it afterwards. I think the data challenge is significantly easier than, say, autonomous vehicles. There's not a requirement for more data to come out every 10th or 100th of a second.
Fair enough. So if I extrapolate then, the combination of sensors everywhere plus some degree of artificial intelligence perhaps would learn and anticipate how often sampling would even be needed.
Yeah, absolutely. You'd identify when your sampling would be needed by kind of how quickly do these problems evolve, and you'd also be using your artificial intelligence, and it doesn't necessarily need to be that sophisticated. To take the vibration example, you've got a threshold where you're happy if the vibrations are within that range, amplitude and frequency. As soon as it moves out of that frequency or amplitude for a specified period of time, then some kind of alarm sounds and a manager or maintenance person gets alerted. These kind of algorithms are not particularly different for those that you might get in an intensive care unit for patients, where they'll monitor your heart rate, and if it moves too much from a set of parameters, it will issue some kind of alert. Those have been around for years, but obviously that's a higher value use case. But you're applying fairly similar ideas, but now much more widely across factories.
I'm guessing you talk to a range of companies, OEMs, actual equipment manufacturer, I should say product manufacturers and so forth, in the course of preparing your white paper and perhaps across a variety of regions as well. Is that a fair statement?
Yeah, absolutely. And so we've spoken to companies that make the manufacturing equipment. Some of which are quite big, like say Heidelberg, who make printing equipment that are very much looking to kind of offer full solutions. We've spoken to a lot of sensor providers. We've also spoken to research institutes that have sort of set up pilot lines with all of this technology kind of built into them, so that companies can see what's possible. And so that, these are happening everywhere. And often for sort of SMEs, they're not necessarily aware. Some are, but maybe not all of them are aware of what is possible and what the technology can offer them. And so there's quite a lot of interest from governments to facilitate that kind of process by having these pilot lines, and people can see, oh well, we've made all of this is automated, or we've got all this predictive maintenance happening here.
Did you uncover any regional differences in what I would say is the current implementation?
There's obviously a kind of trade-off with wages here. So broadly speaking, it's the more kind of developed economies where wages are higher, where probably unsurprisingly, where doing more of this kind of factory automation makes commercial sense. And so that's part of the sort of aim of reshoring. As I just discussed, in that if you're going to move manufacturing back from lower wage economies, well, you've got to automate an awful lot of it to keep it cost effective. And so that's sort of one of the motivations. And so you see a lot of interest in kind of high wage economies like Germany and Scandinavia, a lot of effort going into it there. But I think the kind of reshoring trend is sort of happening in general. And I think that these kind of technologies, at least ideally should be able to do that without, say, doubling the price of everything. The wages are higher, but you need fewer people to run your line. It needs repairing less often. It needs maintenance less often. It needs checking less often, because all of that's been done digitally.
And of course, I teased the reshoring, and I haven't really got into it yet, but the cost, of course, is a big limiter. And, that's one reason why people outsourced to different regions in the first place, to lower cost regions, was to take advantage of lower labor costs. At this point now, much of the supply chain has been built around these centers, almost these extraordinarily large campuses, and in some cases they've turned into full-fledged cities on the Pac Rim that are essentially self-contained supply chains. Getting back, you mentioned a little bit about the SMEs, which for folks, I'll just explain the acronym. It's small or medium-sized enterprises. Does your research attempt to assess the CapEx for various sized operations?
We haven't looked certainly haven't looked yet at the kind of capital that's required. There's so many different types of factories out there for manufacturing so many different types of things. We've primarily focused on the technology, the sort of hardware technologies that will sort of facilitate this transition. But certainly, to give a few examples, we've seen a Japanese PCB manufacturing company. They've got a novel method of making PCBs, and they've got a lot of interest from Toyota, who are keen to bring some of their PCB manufacturing back to Japan. Just as an example, obviously Toyota being a household name. And as you kind of hinted at, there's all of these sort of supply chain security concerns, sort of geopolitical tension, all of that kind of thing. And obviously there's a price that people want to pay. And then these technologies are a way of being able to meet those supply chain security requirements and sort of geopolitical considerations without having to pay loads more for everything. How much does it cost to get all of this stuff installed to digitize an existing factory? It's a difficult question, because obviously all the factories are different. But there are technologies that are being developed to make that cheaper than you might imagine. So, for example, you don't need to buy completely new machines. There's some projects in German research centers, the Fraunhofer Institute, utilizing 3D printed electronics to make bespoke sensor housings that can then be integrated into fully depreciated, quite old equipment that still works well. So if you've got a bit of heavy industrial equipment that is old but works fine, and you want to digitize it, you can still add sensors to it without having to spend all the extra money on the entirely new piece of equipment. And a lot of these sensors, can be quite simple. And the thing people talk about things like, sort of sticker electronics, which aren't necessarily quite there yet. But there's kind of energy harvesting tool approaches that people will use so that this stuff doesn't need to be wired in. You could just, get a magnet, stick something on, it will harvest energy from the vibrations, use some edge AI, send the data back, and that whole unit might be a few $100s. So it doesn't necessarily, digital factory doesn't necessarily mean spend millions on new equipment. It can mean make some judicious investments, have some kind of subscription to some kind of software, and install a selection of relatively low cost sensors, which may in some cases require sort of bespoke housing, depending on the equipment or where you're attaching them. But it certainly shouldn't mean, okay, we need to sort of fully refit the factory here.
What I'm hearing is that just like there are a wide variety of factory layouts and processes and focuses today, that won't change with Industry 4.0. The implementation of sensors and cobots and some of these other things that you've mentioned, they will be implemented in a specific and an individual way. We won't see just a generic factory where everyone has sort of the same kind of line and information collection and so forth.
Yeah. So I absolutely agree. I mean, I think it's just gradually, just like your sort of life at home, you'll just more and more things will kind of gradually become digital. And just so 5 years ago I didn't have a smartwatch, now I do, and so these things kind of gradually progress, but there's no need to kind of go for a kind of wholesale readjustment here. You could identify, okay, I have this machine, I don't really know why it keeps going wrong. Maybe I could get some advanced warning if I installed some sensors here, and probably without knowing it, you suddenly sort of become part of Industry 4.0 because you've now got some continuous monitoring enabling predictive maintenance on this particular machine. So it's not a sort of, I've got to start with a blank piece of paper and a huge check and a thick checkbook. It's okay, I'm going to make these kind of incremental improvements to take advantage of new low-cost sensing technology, improvements in energy harvesting, wireless transmission, and particularly the relatively low cost of cloud services and data processing to try and solve kind of particular problems within my factory. I keep running out of this equipment because its use isn't linear and I don't know when to order it. Okay, great. Can we put a sensor in here to track when that's about to run out and order it automatically? This equipment keeps breaking down. Okay, and I don't really know why. Okay, can I check that? My maintenance people keep making mistakes installing this stuff. Can I put something in to check? And then there's also on the maintenance side here. There's also an interesting kind of placebo effect here that if you start adding the ability to monitor how effectively maintenance has been performed, you apparently see the maintenance being performed better, even if you don't go and check afterwards. So if you to go back to this gasket example, if you make the gaskets able to record whether they were installed correctly, then a much higher proportion will be installed correctly because people now know that they're being monitored. And so you end up with these kind of sort of perhaps unexpected benefits that by better monitoring how various tasks are performed, perhaps unsurprisingly, people on average will perform them better, and you can still identify the odd mistake.
So that's fascinating. Is that something that you observed yourself, or is that something that in the course of your research and interviews, it was brought to your attention?
This is something I've been told by or seen in presentations from multiple people, and so different unconnected companies. One of the more interesting ones, which isn't quite a factory, was you can install moisture sensors. Swedish companies developed a device to monitor moisture levels behind tiling in showers, and you just scan it with an RFID scanner. It's just a little coil, and the frequency changes with the amount of humidity. And then they discovered it. They discovered that all of their showers were being installed much better once people started putting this stuff in, and they were getting far fewer. Whoever, the building company or whoever was getting far fewer kind of callbacks, going, 6 months later my shower's leaking. Once they obliged their staff to install this device, and of course the device doesn't actually need to work. It could just be a piece of plastic. But if you tell everybody, this will enable us to monitor whether your bathroom leaks, you find that actually people will kind of improve the quality of their work on average. So there are kind of other benefits which you wouldn't necessarily anticipate. And I think you can certainly get those kind of in a production sort of factory setting as well. That it is more things are monitored and maintenance tasks are easier to check. Just like you would get with quality control on the product itself, which is already well established, you can now get quality control on all of these kind of repair tasks as well.
Never forget, Big Brother is watching.
Well, yeah, I suppose that is the downside, but there we go.
So we talked a little bit about AI. What role do you think AI will play, and do you think it will vary by region, perhaps in part due to governmental constraints on what algorithms are actually going to be permitted to do? I mean, that seems to be up in the air at present.
Yeah, so first of all, I'm not an AI expert. I think you can get quite a long way by doing actually relatively simple data processing of the kinds that I described, checking that parameters are within thresholds and things like this. When it comes to doing sort of more sophisticated things, you're looking at kind of object recognition, that kind of stuff. And I don't think that there will be, because you're monitoring an industrial process with kind of employees who are all kind of consenting to be there. I think you're going to get a lot fewer issues than you do with things in a kind of more of a consumer context. It's not quite the same as monitoring people's movement around a supermarket or something. Everyone there is an employee. You're not necessarily monitoring them. You're monitoring the equipment. How that evolves and how automation kind of works its way through the workforce is a much bigger topic than just talking about factories for the future, and how that kind of progresses politically is kind of an open-ended question. I think in most cases, your option, this is technology that will facilitate the reshoring because it will enable you to manufacture more efficiently. And so, given that there's a kind of political tailwind kind of pretty much across the West and Japan as well, maybe Korea, to kind of bring high value advanced manufacturing back home. There's statements, as I've written in the white paper, statements from Biden, from an EU commissioner, that they want more advanced manufacturing. These are the kind of technologies that can facilitate that. And so, if you're a sort of labor union, I wouldn't necessarily see it as, oh, this is a threat to our workers' jobs. I'd see it as, this is an opportunity to have maybe more jobs, or certainly have more manufacturing, and hence people can do higher value tasks, and we can get more of the manufacturing that's currently been taking place elsewhere can take place close to home. We can get the environmental benefits of less logistics and those kind of things. So I think I think the pros kind of outweigh the cons. I think that your data protection sort of issues are less they're insignificant, but I say they're less significant than in a consumer setting. I think it will just sort of happen gradually. There won't be a kind of big bang and all of a sudden this sort of happens. You'll just get gradually, the equipment will become cheaper, will become more established. People become more comfortable with the kind of data processing and the data dashboards, and how they could use this to actually improve the output or have less downtime. And it will just sort of gradually make its way in, so that it becomes kind of the norm. Just like mechanization did, 100 years ago, or the production line did 100 years ago, and it would just kind of become standard. And clearly, there's opportunity to do kind of increasingly sophisticated machine learning and work with much larger data sets for stuff like object recognition. But there's a lot of benefits to be gained just by monitoring the temperature where temperature wasn't monitored before. It's very simple, but actually that could have some. There's not really any AI there, but it can be quite tangible, offer some quite tangible benefits.
Back in 2020, I interviewed the general manager of Universal Scientific, and did sort of a virtual walk through their facility. It was actually during COVID, but they had over the previous year or 18 months, they had converted a heavily manual operation to an almost completely touchless operation, with AGVs moving product from floor to floor, bringing material to the lines, 8 SMT placement lines, all side by side by side by side, in a single line configuration, no conveyors at all between those machines. They, of course, were building millions of parts. This is a top 10 EMS company in the world. They have very deep pockets. You were just a moment ago talking a bit about the implementation and what it would look like, from the SME's vantage point. What it sounds like to me is this will be one of those things where we don't realize just how widely the factory of the future has been implemented in real time. It would be more that we look back and get a sort of a retrospective glance and say, oh, okay, the turning point was here, but we won't really know it when it happens. It'll be more after the fact.
Yeah, absolutely. And I absolutely agree that there's plenty of kind of highly automated manufacturing lines already, of course. It's more the sort of idea that can we take sort of existing older equipment and then make it digital, make it smart. Can we digitize things that probably even in the factory that you described maybe aren't digital? I've had discussions with people who are looking at trying to make kind of various types of sealants on pipes and things, leak sensing, and at the moment that's not really happening. And so it's those kind of pretty arguably quite mundane things. It's not necessarily the fanciest equipment, but can I ensure that this, I get early warning of any leaks in all of the pipes in this factory? That's some of the ideas that we're looking at here, and people are busy developing new technologies and new materials that will enable that kind of relatively cost effectively. But there's also the kind of aspects that you might have guessed that my colleague primarily wrote the cobot section, where that's kind of a slightly bigger scale, where we'll end up with more and more kind of automation that is maybe what people think about when they think about a digital factory. They picture something with a lot of robots, with cobots, maybe an Amazon factory with automated stock pickers and all of this kind of thing. And I think all of that's running in parallel to the kind of things that, to an extent, it's already started, to the kind of things that I've described, which are a sort of smaller scale. But it's also what I've been describing would also be kind of monitoring the health of the cobot. Is everything going well there? Or are there any bits that are wearing out too early? Are there any screws that haven't been threaded correctly? And all of this kind of thing. It's about monitoring as much as you can to identify, to either stop problems happening in the first place or identify any problems before they become serious.
The paper from ID TechX is called Factory of the Future. And Matt, where can people get a copy of this?
So you should be able to download it from our website. And on there, we also have a list of all of the market research reports, including ones on sensors and 3D electronics and cobots, collaborative robots, and of course, many other topics as well.
Great. Our sponsor today has been PCB West, the leading conference and exhibition for printed circuit and design engineering, coming October 4th to the 7th to the Santa Clara, California Convention Center. Learn more at PCBWest.com. And I'd like to thank our guest, Dr. Matthew Dyson of ID TechX. For PCB Chat, this is Mike Buetow. Have a nice day.